So, one intriguing thing about these things that I've never had properly explained, or never seen properly explained, is the fact that when they actually blow, the rest of the lights keep working, when normally you would expect a bulb to blow, it would go open circuit, so there would be no current going through any of the others. And I've looked at a video or two on YouTube, I'll give Fran Blanche a mention, but still not specifically had what I think is a comprehensive explanation. So while I was tidying up at the end of the first Fairy Light video, I discovered I had, and I marked it, actually still got a blown old bulb. So we've got one here that's working. If we take that out, they all go out, and if we put this in, the rest come back on, but this doesn't. So why? What is going on in here that allows the rest to be on? And well, after this one's blown. Okay, so here in our little holder that we chopped out of the spare set, we have our bulb. Power supply set to 12 volts, and if we connect it up, that's the good bulb, the little light comes on and it is drawing 54 milliamps. Okay, here is the blown bulb. Remember, this was conducting when it was in the string of light, main string of lights, because the rest of the lights were on and they're all in series. And if we plug that one in, we get no milliamps. So how strange is that? So what happens if we plug that into our string? I wonder what voltage there is across it to actually enable it to conduct. It's like there's some kind of a Zener or something in there. Okay, so we have a couple of sewing pins stabbed into the cables with exposed crock clips going to the meter. So only slightly dangerous. However, we have in our working bulb, so let's see what voltage we measure across there. I will turn it on over here. Interestingly, 9.36 volts AC. We will leave that problem to one side for the minute and put our blown bulb in. 0.1 of a volt. Most strange. 0.15. So now let us go over here. We'll unplug this from here and put our meter on ohms. Interesting. 5 ohms. Right, we have an ever more flaky setup here. So we have volts AC on the meter measuring across the bulb. We plug it in and everything lights up. You just see they are all lit apart from our broken one, and that is registering 80 millivolts. That is effectively short circuit. So just to confirm that, shall we unplug it again, and you'll see why I'm unplugging it all the way in a minute, and switch the meter to ohms. Alright, 1.7 ohms. A bit of contact now with the wire. So we're unplugged, and checking this every time, because I don't want to connect mains to either my meter on ohms or my power supply, either of which will cause serious damage. And we plug it in, 12 volts, not a milliamp. That is not short circuit. Okay, so we plug it back into the meter, and it's giving us 2 megohms. Open circuit pretty much. So if we switch the meter back to volts AC, just double check, plug it in again, and the lights come on, and it's obviously conducting. Unplug it again, flip the meter to ohms. There we go, very low resistance. Now if we take the power supply, switch the power supply to 0, plug this in, doesn't matter, and bring the voltage up. Doesn't matter, we have current, it's short circuit. And if we wind this all the way up to 12 volts, still short circuit. If we unplug one of the wires, plug it in again, nothing. Well, that is pretty weird. That is a weird thing to have in a small bulb. And as I sit here, I don't know what on earth would cause it to behave like that. I do actually have, I'll zoom you out here, well, that one's a duffer. I had more spares of these original bulbs than I thought I did, which is nice. So I might, without breaking the budget, see what happens when one of these blows. So this is one of the new ones that I'm going to blow it deliberately. So what I'm going to do is, firstly, I'm going to take this plastic base off, which should hopefully come off easily. Yes, no, maybe. Oh, there we go. So we can see the whole of the insides of the bulb. Actually changed tack here, just plonked it down on the bench, soldered a couple of bits of wires to the end that the crocodile clips will grip. And if we zoom this in, alright, yeah, it's going to focus there. This is at the limit of what the camera will do, and every time I knock the bench it shakes. So here we can see the filament, and here we see a curious piece of wire wrapped around between the two wires that supply the filament. Now, I was always told, well, I have it in my head, I don't know whether I was told or told once, or I made it up, that when the filament blew, there was some kind of contact that flipped over and switched it to, well, I thought short circuit. So all the other bulbs were running a bit brighter, but still running as long as you came along and changed it fairly shortly. So I don't know. So what we're going to do, because I haven't got a blown bulb, I've thrown them all away, we're going to blow this bulb. So what I'm going to do is, so I've set the power supply to 31 volts, and what I'm going to do now is give it a blast of that, and that should blow the filament, so we can see if anything happens in there other than the filament blowing. So here goes. Come on. Huh. Well, there it is, holding on 31 volts, you tell me. Huh. and the camera doesn't like it. That's done something horrible to the filament. Let's see. Nope. 31 volts, 113 milliamps. Well, what I was going to do when I blew the filament, which it doesn't seem that I can, is I was going to try and get in there. Basically break open the envelope and get in there. So I'm thinking, well, if that process doesn't break the filament, then if I fire it up in air, the filament will pretty soon burn out and the camera won't focus. So what I propose to do is wrap a piece of clear tape around it to stop the glass going everywhere. So here's my tape. I'm going to take the bulb and wrap a run of that round it. So that should catch any broken glass. We hope, and I'm going to take my little vise. Okay, hopefully here we have a chunkier vise. No D in it. So let's see if that'll do it. Yes, there we go. So I now have a bunch of broken glass all taped together. Yeah, it's going to spit some bits out, which I have to try and get off the base. So let's see if I take my scalpel. Let's see if I try and cut some of this tape. Alright, managed to tease it apart, and looks like the filament is still intact. So I suspect putting 12 volts across that in air, it won't last very long. So unfortunately, bits of glass there hiding that coil of wire a bit. Anyway, I will get it set up and connect 12 volts across it, and we can have a bit of a laugh anyway. Okay, so here we go. Just wind the voltage up from nothing. Okay, well that has blown and it's not drawing any current. Right, ever flakier. I have a broken bulb connected by these old and rubbishy jump leads across our pins, so we're now going to find out if that bulb is still working as a blown bulb. We'll go short circuit and the rest of the lights come on, and obviously I have no bulb in here. Okay, we're plugged in, we're not turned on. Shall we turn her on? Yes. So that bulb is still working as a blown fairy light bulb. The rest of the lights have come on. Right, disconnected. None of the lights come on and we get 240 volts across there, so I might turn it off again quickly. Okay, taken with a magnify kit on my phone, because I don't have a microscope that I can record video on. Maybe I should get one. Anyway, this little here piece of wire has got to be what's doing our short circuit, open circuit trick. So I'm going to get my binocular microscope out and try and detach it. very carefully so we can have a look at it on the desk. Okay, I am looking through my binocular microscope and I've got the camera set up next to me doing its level best to focus in on something very small. So let us see if we can get this fancy piece of wire off here. Oh, well, that's strange, it's not actually attached on, it's just slid over. Doesn't look like it'd make contact, to be honest. If I slide this way, pull it off, not really bad. Well, there we are, one fancy bit of wire. Okay, so I have stuck this tiny little thin piece of wire with double-sided tape to a piece of paper, so it doesn't get lost, because it was just every time I breathed out it was blowing across, blowing away. So here we have our ohm meter, so let's see what this gives us. Not many ohms, and that's just trying to get good contact on it. So, okay, seems probably just like a piece of wire. Let's try our 12 volt test on it. Okay, power supply set up to 12 volts, I think it's 80 odd milliamps. Short circuit current, and we have it connected to these probes. There you go, 86, 10 millivolts. So that looks to me like just a piece of very fine wire, and just when I was trying to unwind it with the tweezers, and it is hard to tell on something that fine, it did not seem to be like copper. It didn't seem to have that spring to it that copper would have. It seemed more like solder, so what sort of wire it is I don't know. So where does that leave us? Okay, so we have a blown bulb which has a bit of wire, which you can't see because of the plastic holder, which seems to be loosely wrapped round the two wires sticking up that have the filament attached to them. So we took this bit of wire off, and it's just a bit of wire, and it was only seemed to be fairly loosely slid over the two copper wires going up to the filament. And this is the one that it came off, and this worked as a blown bulb, went short circuit when we put it in instead of a bulb. So now it hasn't got its bit of wire on, shall we try this just as a sanity check? Okay, plug it in and fire it up. No, we do not get any lights on. Yeah, that one's in shot, isn't it? So if I very carefully, because there's lots of live mains on here, don't try this at home, people. What was that? Plug this bulb in. Yeah, it starts. That's the blown one, and it's not come on, and the others have come on. So that little bit of wire wrapped around there is what's causing our mysterious short circuit when the filament blows. Okay, so here we have what's called a fuse bulb. Tell by the white paint at the top, and that doesn't have this clever feature of going short circuit when it blows. That's so if they all start going short circuit and the voltage across each bulb increases, well, if you had 20 short circuits in a row, it could set fire to your Christmas tree. I don't think it would just blow the plug fuse, but anyway, this one doesn't. So when this, if the voltage goes up too much across this one, it'll blow. And there's a 1 in 20 chance if one of them blows, it's the fuse one and they all go out, but there you go. So this doesn't have our fancy keep the rest of the lights on feature going. So if I turn this on now, there we go, we all light up. Okay, we have our blown bulb here, no bulb in here, and let's look at the resistance of that, which is a few ohms. Okay, so I am now going to take these wires out of the meter and connect them into 12 volts in the power supply. You're taking my word for it here. And connect it up, and I can tell you there's no current being drawn. And if we put it back in here, we get open circuit. So we've seen that before. Don't know how come putting 12 volts across there resets it, but it does. So let's put our fuse bulb back in. So now this should be open circuit, we think. Let's just put it back to ohms. 20 ohms, yes, that's the resistance of the bulb. So this bulb should light along with all the others, which is what we in fact see. So again, trying not to touch any of this exposed mains wiring. I take that bulb out. I've just pulled it up so it's not connected anymore. You can see the bulbs are all on and that bulb is out. So if I now push that bulb back in, that has remained short circuit, because if I now pull our blown bulb out, there we go, that bulb comes back on. Well, here we are, and to be honest, at this point I've had enough of messing around with bulbs, which we're only using because they're a sort of family heirloom, otherwise they'd be well into the electrical recycling, we'd have some LEDs. But very curious things. So we've discovered there is some mechanism that when it gets 240 volts across it becomes short circuit, and can be reset if you connect 12 volts DC to it. And it appears to be just a piece of wire wrapped between the two ends of the filament. So I can only think there's some sort of coating on the copper wire that it's wrapped around. So if anybody has any idea how these things actually work, I'm sure somebody's sitting there thinking, oh God, don't you know that? Well, please leave a comment, because I would really like to know, but for now I think I've just had enough of playing with these. I've got plenty of other interesting things I'd rather be getting on with. So I'm going to call it for this video. Hope you've enjoyed it. I know it's not the most exciting of stuff, but sometimes I just get off on one of these tangents and want to know something, but I've got to discipline myself and get on with projects rather than messing about with bulbs. So I'm rambling here, so on that note I will leave it for this video. So it's goodbye from Triplicate. Goodbye.